All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue learning about ESP32 Rust development. I think I'm getting better at that specific intro. Yeah, we're going to call this ESP32 Rust development because we are doing two things. We are learning about the ESP32 itself, and we are learning about doing no STD Rust development for the ESP32 using the ESP HAL. Um, yeah. So, I don't think I've made too much progress between yesterday and today, at least in this on this front, because I got busy doing some other research. Um, I did also, so in not yesterday's stream, but the stream before that, we were talking about the CH32V003, and I after that stream, I went and did research on this microcontroller, and one of the things, as I mentioned at that time as well, one of the main appealing factors for me was the price. It was incredibly cheap, so cheap that it could be considered half the price of an ESP32, um, or maybe two-thirds the price of an ESP32. And that's great. That's amazing. I don't mind if it's a low power device, because if I need something that's meant to be doing much more higher, how do I say this? If I need something that's meant to be doing a lot of processing and needs a lot of performance, then I can use one of my more expensive yet still cheap microcontrollers, which is the ESP32. But I have a lot of projects where I would love to have a throwaway microcontroller. And I say throwaway, but that makes it sound like I'm going to use it once and throw it away. But no, I mean incredibly cheap microcontrollers that I can just quickly, program to hack some specific type of appliance or electronics or whatever. It could be incredibly useful for that purpose. Another thing it can be very useful for is controlling different sections um, of a robot. Because within robotics, within a robot, you won't always just have one microcontroller. For different sections, you might have different microcontrollers, depending on what the entire design is like. But for different sections, you might have different microcontrollers. And having, if these are like tiny tasks that don't require a whole lot of processing, a whole lot of thinking, if these are just tasks that um, where it's like you give the microcontroller an instruction to do this and that and that and that, and the microcontroller should do that. That's it. If you have that kind of situation set up, then having one of these low power microcontrollers can be incredibly cost effective for you. So that's why I was spending some time doing research on it, and I'm glad that I did the research because there is a lot that I did not know about this specific microcontroller. For one thing, this specific microcontroller actually requires a separate piece of hardware for flashing the binary onto the microcontroller. You can't just connect via USB, or at least that's what I've been told while doing research through Gemini, that this microcontroller or the dev board for this specific microcontroller, it lacks the hardware that is responsible for the flashing, and so um, you can't just connect. I mean, it has a USB port, but through that you can't really flash a binary onto it. To flash the binary, you need something called the WCH link E. This is a cheap hardware programmer slash debugger, or flasher slash debugger, that you can get. it's a proprietary device by WCH, which supports the protocol required for flashing a binary onto the CH32V003. And it turns out the E part is also necessary. I need to make sure I'm getting an E, as in link E, not just a link, because apparently the E part, um, I don't remember exactly what it stands for, but the E part is what, or rather, I should say, the version that has E in it is what's able to program the the CH32 V003. Um, Otherwise, I'm probably not going to be able to program it. And the good news is that this hardware is super cheap. I can like buy it once and I'm good to go. And it's not like I need, you know, three or four of these. It's a programmer, so I just need one of them. And yeah. So I'm considering getting it. There's also um, the tool chain itself. The development workflow for this, what do you call it? The development workflow for this microcontroller through Rust is a little different than the more streamlined workflow that we have on the ESP32 side. So while I am excited to get into the CH32, I'm probably gonna hold off on it for a little bit. Whenever I get my first CH32, I'm definitely gonna check it out. I want to make sure that what I've bought is working. So we're gonna set up a couple of like simple circuits with it. But and who knows, maybe once I've done that, I might not think that the difference between the workflow is that much of a headache. Um, but yeah. I mean, it's not really a headache. It's more that I'm currently still a beginner in ESP32, so I guess I don't want to have to um how do I phrase this? So I have to learn both of these, right? I have to learn how to program both of these microcontrollers. In addition, I'm also going to have to learn both of their separate workflows. Fortunately, again, on the ESP32 side, we have a much more streamlined workflow. A bunch of the boilerplate stuff is done. A bunch of a bunch of details and stuff that need to be added, a bunch of configuration, I should say. It gets handled by ESP Generate, which is their tool for generating Rust projects for ESP32 development. All of that gets handled for you. On the CH32 side, I don't think they have that. I think you have to build things from scratch. But like, I'll have to Google more. I haven't looked too deep into it. I've looked into some articles that people have written for this. Um, but um, those articles are minimum 1 or 2 years old. So I don't know between that time and now if there's been some more development. I'm guessing now. I, I, I mean, I'm assuming people are still working on this. So, and since this is a pretty cheap microcontroller, so there's probably going to be a lot more development on it as well. Hopefully, people start, contributing more to this ecosystem as well, just as much as they're contributing to ESP32, and then we can see more development on this front as well. But yeah, I've been doing a good bit of research, and this has taught me that before I just rush to buy one of these things, I should absolutely do all the research that I can, not just about the hardware, but about also being able to program the hardware, because I had no idea that you absolutely need a separate flashing hardware, a separate flashing device in order to flash the binary onto the CH32V003. Some of the later versions, they do come with the hardware necessary for flashing the binary directly onto onto the microcontroller. But this specific one, this low cost one, this doesn't have that. It is, I mean, it makes sense that it's been stripped away of a bunch of different things to make it cost effective, and I guess this was one of the things that got stripped away. It turns out that in order to flash this binary onto in order to flash a Rust binary onto this microcontroller, you need a very specific, or it uses a very specific protocol, and apparently that's a proprietary protocol, um, which their own hardware, which is very cheap, their own hardware is able to do that very well. There have been open source efforts to kind of recreate what that does, but it's because it's a proprietary thing, so a lot of those efforts are relying on reverse engineering, which may not necessarily always get it right. And according to Gemini, you would save yourself a lot of headache if you just go and buy that cheap hardware. And yeah, Gemini is right. It's cheap. It's like $2, $3, maybe a little more. You could save max $4 or $5, and it's not like you have to buy it over and over again. It's one device that you have to buy, and then you can use that same device to flash multiple microcontrollers. So a lot of people prefer to just buy that one cheap device, and it saves them a lot of headache. A lot of the other stuff is open source, like the entire like Rust, um, the Rust side of things is very much open source. I don't know if there's any part of it that's closed source, any part of the Rust side. I mean, for the CH32, I haven't looked into it that deeply to know if there's anything that's closed source, but for the most part, there are a lot of open source things on that side. But this one specific thing is a proprietary device that you have to buy, a proprietary protocol that's spoken by this device that you have to buy. And I'll be buying that device as well. And this is why I'm glad that I did the research. Throughout the research, by the way, it just so happened that Gemini mentioned that pay attention to the E, because otherwise you won't be able to program the CH32V003, and I'm going for that specific model, CH32V003. It's a V0 model. So if I bought a link, if I bought a WCH link and I didn't know how to program it, and or rather I didn't know that you need a specific device, a specific version of the device to program this microcontroller, I probably would have wasted my money, which would suck big time. To be fair, I think what would have happened in that case is I probably would have ended up then buying some other CH32 microcontroller that can be programmed with the wrong flasher that I bought, and then I would have gone that route, but it would still suck. It would definitely still suck. This has me curious though. I need to check if there is a chance that I would have accidentally bought the wrong one. So let's say WCH link, link flasher. Okay. Um, so fortunately, when I look up WCH link, it doesn't show link. It immediately shows link E. Um, so that's great. There is also link W. That's interesting. I didn't know that's a thing. But yeah, the link E is pretty cheap, and I am probably going to be buying this. No, no, if I'm buying the CH32, I'm definitely buying this because, I mean, otherwise I can't program the thing, right? So I need to buy this as well. And I'm kind of excited because I looked at I looked at some of the code examples, And fortunately, um, and I think this is thanks to embedded HAL rather than uh, thanks to the CH32 HAL itself. I think this is because of the embedded HAL, because embedded HAL has a standard set of traits that need to be implemented by whatever microcontroller HAL is being implemented, because that HAL is implementing embedded HAL. It is um, wh- what's the what's the compatible? There you go. Uh, 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 shit! I lost my. Um, hold on, hold on. I need to get my thoughts back, get the words back. Wait, a HAL that's being implemented for a microcontroller, um, a HAL that is meant to be embedded HAL compatible. There you go. This HAL has to implement a bunch of traits from embedded HAL. And because of that, there's a lot of functionality that becomes um, more standard, or rather, I should say, there's a lot of API apparently that that becomes a lot more standard. So regardless of which microcontroller HAL you are using, you can expect the naming convention to remain the same. There'll still be some differences here and there, and there might be the HAL might have like a different API design, maybe. That depends on how they've gone about doing things. But a lot of the naming convention would remain the same. So you can kind of guess if you've learned how to use one embedded HAL um, driver, I guess I should call it one embedded HAL library like ESP32 HAL or ESP HAL. If you have learned about ESP HAL and you are comfortable with that API, then I'm assuming, okay, I haven't tried this yet, but I'm assuming if you have learned the ESP HAL and you're comfortable with it, you know how to use that API, you're going to be able to pick up CH32 HAL pretty quickly. It's not gonna be such a big challenge for you. It's not going to be such a big headache. There'll still be differences between the two, but I'm assuming it's not going to be that hard for you to pick it up. And I'm hoping that, yeah, it's not that hard to pick it up, because that'll mean that I'm able to jump into the CH32 uh, coding pretty quickly, and I'm able to start using CH32 in a bunch of different projects fairly quickly. Actually, something else that I definitely want to add to my projects. I have no idea if I want to do this on stream or not, because this is going to be extremely risky the first time that I'm doing it. It's also going to carry a risk like throughout each time I do it, but really it's going to be risky doing it on stream. Forget about first time or second time. Um, I want to test out the relay modules that I have. So for those of you who don't know, relay modules are used when you want to. Let me explain what a relay helps with. Then I'll talk about the module. Um, the relay itself is used to allow you to basically create a sort of switch in between. So think of it as a electronic switch, but what's happening is that you give the relay a small signal, and based on that signal, a small signal on one of the pins, and based on that signal, it trips some kind of switch internally. I think it's a solenoid. I'm not sure, but there's a mechanical switch inside that physically moves in order to close the circuit and allow current to flow through. So the way that it works is you have a relay. Um, just conceptually, you can think of it. You have a relay. You can connect. Let's say wherever you live, there's the mains socket, it uses 240 volts. So you can connect the 240 volts into that, and the other side of that can be connected to, let's say, a lamp, a table lamp that's supposed to take 240 volts. So generally you would just connect the lamp directly into mains because it's meant to be connected into the wall socket, right? It has circuitry to handle all of the conversion of like the AC to DC, and stepping down the voltage and the current and all of that stuff, smoothing out the current and all of that stuff. It all of that circuitry is already there. But you have to connect this into the wall socket, and then you have to turn on the switch so that the light can go on, right? What a relay does is the relay would sit between this table lamp and the wall socket, and it's essentially um, a switch, or you can call it a circuit breaker kind of thing. I don't know if I should be saying circuit breaker there, because circuit breaker is used in a different scenario. But you can think of it as a switch. It's more or less a switch. So it sits between the table lamp and your wall socket, and then you can give this relay a small signal through something like a microcontroller, for example, and that'll flip a switch internally, which will let current flow from one side to another. So from the wall socket side to the table lamp side, it'll let the current flow through. So this way, you can use a microcontroller to essentially power on and power off these devices that are meant to be connected to home appliance these home appliances that are meant to be connected to wall sockets. So that's one of the ways that relays are used. You don't directly use the relay because there's a lot of circuitry that has to be built around that. Generally, if you are doing it especially through a microcontroller, you would use a relay module. So the relay is in the module itself. The relay is within that PCB, and there's a bunch of other circuitry there, including pins to allow you to connect a microcontroller in. So a relay module is what you're looking for rather than just a relay. Um, Let me hold on, because a relay module, it definitely solves certain issues that can arise with just a bare bones relay. Okay, so I want to use a relay module with my ESP32. Everything is fine, but I'm wondering how different things would be. There's probably also circuitry to, actually no, I was about to say there's probably also circuitry to step down the voltage, or take the level down, but that's not entirely true because that support is part of the relay itself. The relay itself has specs, um, and the trigger, essentially, you can specify, or you can buy relays that have their trigger to be 5 volts or 3 volts. So if you're working with an ESP32 that usually deals with the 3.3 volt range, you want to go for the 3 volt thing. If you're working with an Arduino, then you want to go with the 5 volt thing. Otherwise, you're going to have to use a level shifter, and yeah, things get a tiny bit complicated there, but like it should still be possible, but yeah, things get a tiny bit complicated. Um, okay, yeah, I was asking here, how different would it be than just using a relay? I guess what I'm wondering is what all does the relay itself, no, what all does what all does the relay module circuitry do? Okay, using a relay module instead of a bare relay is a smart move, especially with an ESP32. While a relay is the quote unquote muscle, I just realized this. I keep saying quote unquote, I don't know if that's really how the saying goes, if that's really the term that's used, because we have quote and end quote, but I'm so used to hearing and saying quote unquote. I don't know if that's really accurate. I'm still going to keep saying it, but I'm just wondering. Um, hold on. Let me let me ask Gemini this question as well. Is it quote unquote or quote end quote? The short answer is both are correct, but they serve slightly different purposes in speech. In writing, when in writing we use punctuation marks, but in spoken English, these phrases act as verbal punctuation to show that you are citing. Yeah, okay, I get what they are used for, but like which specific one is it? So, quote unquote, the most common in casual speech, in casual speech. Why use it? It's a quick way. It's a quick way to signal a term is being used in someone else's words or with sarcasm. And then quote end quote is formal or technical. It's used in quoting a long sentence to show exactly where the citation starts and where it ends. Okay, you know what? That's enough for me. Um, it's quote unquote. Great, awesome. Okay, so while a relay is the muscle that flips the switch, the ESP32's GPIO pins are relatively delicate and can't provide much current. The circuitry on a relay module acts as a protective high-performance interface between your low-power microcontroller and the high-power relay. Here's a breakdown of what those extra components of what those extra components are actually doing. Signal amplification. As not as an ESP32 GPIO pin typically outputs about 3.3 volts and can safely provide only about 12 milliamps to 20 milliamps of current. However, a standard 5-volt relay coil often requires 70 milliamps to 100 milliamps to energize. Okay, the module solution. It uses a transistor, often BJT or MOSFET, as a switch. The ESP32 only needs to send a tiny signal current to the transistor, which then allows a much larger current from the power supply to flow through the relay coil. I didn't realize that. Okay, that's interesting. So I guess that's for the switch, like the mechanical switch inside. I'm guessing that that's why this extra current is required. Then there's flyback protection. Relays are electromagnetic. They use a coil of wire to create a magnetic field. When you turn off the power to a coil, the magnetic field collapses and generates a massive high voltage spike. You know what? Back EMF. This is the concept of back EMF. This is something that I need to look into once we get into analog electronics, because this is one of those very interesting things that happens solely because of physics. I mean, that uh, that's not really saying anything. Um, this is one of those things that, like, it's one of those phenomenons that that happens because of physics, and it's something that you should be aware of. And I feel like learning this, how this thing works, not only is it good for, protection against this, but also I might be able to use it in some way. I have no idea what way, but in some way at some point in the future. Because just like this, um, there are a couple of other phenomenons. There are a couple of other things. I'm not even sure what to call these things, but like, for example, and a lot of the stuff, it tends to be centered around um, electromagnetism, and I was about to say RF, but then I think RF also kind of does electromagnetism. I'm guessing that's how the waves are traveling. I believe so. Yeah, I think so. But yeah, yeah. A lot of stuff surrounding electromagnetism is it's really interesting. For example, this thing about never leaving in digital electronics, never leaving a pin in a floating state. Because if you leave it in a floating state, it picks up it picks up signals from the surrounding environment due to electromagnetism. And then now you have this back EMF thing, which also comes up when you are learning about DC motors. Because when you are setting up a DC motor circuit, assuming you're not using like a driver module, when you are setting up a DC motor circuit, a lot of times they'll mention something called a flyback diode, and that is apparently supposed to help uh, protect against this back EMF thing, so you don't send a massive current slash voltage back. I don't know at what point does it get sent back. Is it when it goes off, or is it when it's turning on? Because when it's turning on, DC motors are known to have like a massive just pull in order to get the thing started. Um, that's one thing, but that's not back EMF. Back EMF is the thing going back once it stops. I don't know if back EMF also happens while the motor is running. I think that's something worth looking into. But yeah, if you are setting up a circuit like this, a lot of times people will recommend setting up a flyback diode, and I'm guessing this is also one of those situations. This is making me think that it is in fact a solenoid, because I'd been told that these relay modules, they also have opto isolators in them, optocouplers in them. But I think that might be for a different part of the circuit, not for this, because you wouldn't be using an opto in a situation where high current was involved. They're not meant for that purpose. Though I think you probably do get high current opto isolators. I don't know. I haven't looked. You probably get them. But I think more commonly opto isolators are low current. Though what I'm thinking, as in I said, I think um, that's not based on anything, so I can't really say for sure. I guess here I can ask Gemini, hey, I'm wondering, are optocouplers usually in the low current range, or are there also high current versions? Okay, standard optocouplers are almost exclusively designed for low current range, typically handling signal level currents between 10 milliamps and 50 milliamps. Think of them as a high-tech think of them as high-tech messengers rather than quote unquote muscles. They excel at passing information while keeping circuits electrically isolated, but they generally lack the power to drive heavy loads like motors or large heaters directly. However, if you need to switch higher currents while maintaining that optical isolation, there are several high current variations and strategies. Power optocouplers, these are called solid state relays. Okay, then Darlington output optocouplers. Okay, they have a slightly higher current range, not all that much. Oh, okay. So Darlington is between 50 milliamps and 150 milliamps, so that's not a whole lot. But the power optocouplers, they can handle anywhere between 1 amp to over 100 amps. That's crazy. The use cases are directly switching AC mains power, heaters or industrial so this is like industrial level stuff. I don't think I should be going anywhere near that because I learned this when I was learning electronics, that my research would be significantly easier if I narrow it down and I don't start going into the industrial range, because things are very different on that level. I'm not saying that the physics changes, but I think the physics does get significantly more complicated in that range, and it's kind of different than the smaller range that we are working with. I mean, stuff is also pretty much the stuff is also much more bigger in that range. For example, you're rarely dealing um, with just volts. You're usually dealing with like kilovolts, or I think megavolts is a thing. And in amps also, you're probably dealing with 100 plus or something like that. Why was I talking about this? Oh yeah. So I need to not go too deep into that side. There's also the fact that on that side, um, I think once you go into like the higher range, there's a lot of AC power going on. I mean, I'm sure at some point before using the thing, they probably make it DC or apply some sort of processing to it. But there is a lot of AC going on there, at least from what I've seen. But like I said, I haven't touched that topic. I don't plan on touching that topic because I already have too much to do research on. Oh, wait, give me a second. I just realized that I forgot to open up my chat. Okay, okay. All right, okay. Give me a second here. Okay, also, not to jinx anything, even though I don't really believe in this jinx bullshit, but not to jinx anything. Um, but the Windows 11 upgrade seems to be going pretty well so far. Also, dare I say, things seem a little more smooth than before. The initial run, the very first Windows 11 run, was really, really rocky, and I was kind of giving up on it. I was like, okay, I've made a mistake. Everything is running super slow. Everything is taking like 15 minutes to move, and things are going to be incredibly slow. But I think that was just the first run, the very first run. So everything that I was doing, I was probably doing it for the quote unquote first time. Um, First time as in, first time in Windows 11. That's why I'm saying quote unquote. So maybe that's why it was running slow. So opening up File Explorer was slow. Opening up the Task Manager was slow. The Task Manager was open for a good like 5 to 10 minutes before it became usable. That's what I'm talking about. Like I had to leave it open for a good 5 to 10 minutes. Shit, maybe 15 minutes. I don't know. And it wasn't just that one thing. There were a couple of other things as well. Opening up stuff like the settings window, that took that took some time. And this was all the very first time. So the first thing I did is I asked Gemini that, hey, see, I've upgraded to Windows 11, but I'm on a system that's not so beefy. So what tips can you give me immediately, or what tips can you give me for what I could do immediately to sort of minimize the overhead of the OS on my hardware? And then Gemini gave me a couple of tips for like um, visual stuff, turning off stuff like transparency, and um, there's various visual effects. There's smoothing of stuff, and various things that are supposed to give it a nice look, but that nice look also contributes to the load on the system. And when you are trying to have a system that is running smooth, then those niceties can introduce small moments of lag in there, and you're not really going to have a good experience when you have a bunch of lag going on. So yeah, that's why I wanted to get rid of that. And yeah, I did. I did the best that I could, and for the most part, yeah, like I said, it seems to be going well so far. On the bright side, regardless whether it does go well or not, um, I'm literally only using this system now for streaming. And at some point later, once I have managed to move my setup completely over to Linux, I'm probably just not going to be booting into Windows 11 again. That being said, I mean, in terms of streaming, specifically streaming, things seem to be going fine on this end right now. Um, I would want to leave this as it is for as long as possible. I wouldn't want to rock the boat, for lack of a better term. I wouldn't want to rock the boat too much because things are working. So, you know, if it's not broke, don't fix it. Um, it's kind of broke. It's kind of broke, but it's working. It's working. So I'm not going to try and fix it. At least, I mean, look, I do want to move the setup over to Ubuntu, and it would be great to be completely streaming off of Linux, completely streaming off of Ubuntu. It's just that I've noticed in terms of overhead, the way that capturing is done on the Ubuntu side, specifically for streaming, the way that capturing is done, um, and the way that programs run as well. And this is again specifically the streaming side. It tends to be slightly heavier than on the Windows side. And of course, this would depend on what you are doing. But like what I'm doing specifically, yeah, it seems to be a little heavier on the Ubuntu side than on the Windows side. So for the time being, this setup is working. At some point later, once I don't, once I've created my TUI based, my terminal based VTuber app, um, and then I won't have the extra load of the Unity application having to launch as well. I might actually think about moving the setup over to the Ubuntu side. In fact, at that point, I think even the mic is going to be running on the Ubuntu side. Well, depends. Yeah, yeah, that depends. That depends, really. Anyways, okay. So, let's get back to this. I forgot how we got to this point, how we like at what point the convo branched out. But today we are supposed to be doing this. So this as in, if you look in the bottom left of the screen, this is what we're supposed to be doing. We are going through the Impel Rust for ESP32 book. If you want to read this book yourself, head over to esp32.impelrust.com. This is an open source project by an amazing community of contributors. Um, and they have made similar books for um, a couple of other microcontrollers as well. Dude, okay, real quick. I have another question for Gemini. I've been learning about ESP32 and Rust no STD for ESP32. Um, this has me wondering about the other MCU choices I have, because the Impel Ferris um, project, let's say, also mentions something STM and something Pico. I'm wondering if hold on, I spelled wondering wrong. I'm wondering if these are, I don't think STM is cheaper, though I guess that would depend really. But yeah, I don't think STM is cheaper. I'm not sure. I have no idea about the STM ecosystem. Okay, you know what? That's a good point. I don't know anything about the STM ecosystem. I've seen people making really cool STM or really cool projects using STM microcontrollers. I've seen people making cool projects using microcontrollers by a company called Seed. I don't know what the specific microcontroller is, but it's from something called Seed Studio. Um, there's this person. I don't know if they're still active on Twitter or not, but you can find their stuff on Twitter, on Instagram. Pretty sure you'll find their stuff on Threads. I don't know where they post like you know, officially, like by themselves. At first, I had seen their stuff on Twitter. I happened to see their stuff on Instagram as well. You know, there's a whole lot of like content stealing going on Instagram. Everyone's posting each other's stuff for likes and views and stuff. So that's probably how I came across some of their videos on there as well. Either way, this person's content is that they build essentially sculptures out of electronics, working things, and like the entire thing itself could be a circuit. The entire sculpture itself could be a circuit. They'll build a circuit for something. um and hold on, no, now that I've spoken about it, I need to look it up. I'm sure Gemini will know who this person is. There's a creator online who, wait, did Gemini answer my question about this? Wait, I'm wondering if these are cheaper or more expensive than ESP32, and if I should try getting into them and hopefully use no STD Rust. Okay, then there's a creator online who creates quote unquote sculptures out of electric or electronic components, microcontrollers. Holy shit, my spelling is just going to shit. Controllers, there you go. Microcontrollers, um, peripherals, and so on. Any idea who I'm talking about? Oh, the entire sculpture, quote unquote, is usually part of the circuit. Or no, the entire sculpture is usually the circuit. I want to show you guys this person's creations. It sounds like, yes, that's the person. Mohit Poite, I think. Let's just say Mohit. Um, so Gemini says this. It sounds like you're thinking of Mohit. He is widely known in the maker and tech communities for his freeform circuit sculptures. Instead of using a traditional green printed PCB or green printed circuit board or PCB, he uses stiff brass or copper wires to act as both the structural skeleton and the conductive parts for the electricity. So I'm going to show you guys real quick. I'm just going to look this up uh, on Google Images, and some of their stuff will pop up. You guys can then look up the person yourselves. and you'll find some amazing, and I mean amazing creations. From this person, I had found out about the Seed Studio MCU. Okay, Mohit. Okay, let me just go to images. Yeah, okay. Give me a second. Let me just scroll. Okay, okay. So I'm gonna show it. Let me also. Oh God, what just happened? Give me a second. My OBS kind of. Okay, my OBS is kind of frozen. Well, OBS is not frozen, but like, okay. Um, I'm not able to do anything in OBS right now. Let me try moving. Oh, the entire thing is okay. Okay. How do I go about this? Gi- Give me a second. Give me a second. This is so weird. OBS is just like black screen now. Well, not even a complete black screen. It's showing two windows, but then the thing is just, yeah, that's not helping either. Hmm. Yeah, nope. I guess we do not have browser for the rest of the stream. Yeah, something happened. Unfortunately, can't really show it anymore. I guess we'll just do this research that we were gonna do. And if OBS comes back at some point, then great. Otherwise, I don't even know how I'm gonna be ending this the stream whenever I do have to end it. Yeah, yeah. I don't know. Let's see. Maybe at some point it'll unfreeze. Okay, okay. Let's get back to um. I mean, since I don't have the thing open here, I guess I don't need to. Right. Okay. Okay. So I was looking at development, the development environment. So they were mentioning using cargo bin install. Okay, for this specific um, instance, I would suggest following the official docs to learn the installation method, the way to install the toolchain, because the information there would be a little more up to date. Um, I'm not saying that this information is horribly out of date, but the information there would be a little more up to date, possibly. I'm sure these guys are also, you know, keeping up an effort to keep it up to date. I also don't remember if binstall was part of the instructions there. So for those of you who don't know, binstall is usually, at least from the little research that I've done about binstall through Gemini, cargo binstall is a way to install Rust applications for your specific, OS and architecture and stuff, using one of the pre-compiled binaries. So there's going to be a bunch of binaries that have been compiled for various different, you know, uh, targets. Let's say that's the right word. There'll be binaries compiled for various targets, and depending on your target, you can just have that binary be installed. So you're not recompiling everything from scratch, which is the way that you usually do it. Like if you use cargo install to install a binary, it's going to download all of the source code and then it's going to compile the entire source code and basically build the entire application on your machine. You have plenty of advantages of that, ranging from architecture or platform specific optimizations to um, I can't think of any others, but there are a couple more. I would have to ask Gemini about it, but there are a lot of advantages to that. One major disadvantage is that compiling takes a while, and if you're on a low end system and you have to compile something that causes the Rust compiler and the linker to go into the GBs while they are running, then you're probably going to be in trouble if you are trying to run this um, on a low end machine. I've had situations like that where I almost got into trouble with RAM usage when trying to. What the fuck, dude? That's whoever that was, a fucking horrible sounding vehicle. I don't even know what that was. But yeah, okay. Um, what was I saying? Yeah, usually, if you are on a resource constrained system, then you kind of want to be careful, depending on which project it is. Like, not all projects are going to have that issue. So, depending on the project that you're trying to compile, it may or may not take, a GB or two, or maybe more in some cases, of your RAM while compiling. And that can be a problem if you are worried about resources on your system. So in that case, you probably want to go with the binary, like a precompiled binary. And even just in general, as a convenience thing, the precompiled binary is much better, but it does have its downfalls in that certain things that are, because it's a precompiled binary, so there is no like build script that's watching out for various environment variables that could be changing, that could be different depending on the system that you're compiling it for. There is nothing that's watching out for that. This thing has been compiled with certain assumptions in mind, and if your system is not meeting all of those assumptions, and the program decides to run, the program is still able to run. Certain things here and there might break, and that's certain things here and there might break, and that can be a little annoying, I guess. So I still prefer the cargo install method. But I'm very well aware of how long the installation can take, especially since literally none of the machines that I have would be considered beefy machines. None of them even have SSDs. That's how old that's how old my hardware is, and they're all Core i5s from the previous generations. Um, all of my machines are basically more than 5 years old, more than 6 years old at this point. In fact, one of my latest laptop, I would say, is around 6 years, 6 years old. The best hardware that I have is around 6 years old, and everything else is older than that. So 10 years old, 15 years old. One is almost 20 years old. I don't even know why I was talking about this. Anyways, so they're suggesting using cargo install. I prefer cargo install instead. They're suggesting cargo install for installing ESP Flash. I don't remember if we have to install ESP Flash separately, or does it come with ESP generator? I don't think it does. I don't think it does. Yeah, I don't think it does. I think I had to install it separately because the flashing utility is separate from the generation utility. They're not the same thing. But anyways, okay, let's read this. So it says, I mean, all of this is, I don't know why I'm bothering with reading this, because it's talking about stuff that I already know. So it says development environment. The official docs provides more comprehensive setup instructions. However, I'll quickly cover the essentials. Okay. Um, this tool, this is to install Rust binaries without building from source using cargo install or manually downloading packages. Um, what this tool? Oh, okay, okay. You can use cargo bin install. We'll use this tool to install the ESP Flash tool next. Sorry, zoned out. Okay. Then ESP Flash. ESP Flash is a serial flasher utility based on ESP tool.py for Espressif SOCs and modules. This will be the tool used when we are not using probe RS to put our code into the device and run it. Okay, if you encounter any problems, you can try installing the exact version used when this book was written. Okay, all right, great. Then we have templates by ESPRS. We will be using the templates provided by ESPRS, which offer two sets, ESP generate and ESP generate, which is a no STD template. This is the one we will focus on most of the time, and ESP IDF template and STD template. So we are not going to be touching that one. We're going to be going with ESP generate, and I mean we're already using ESP generate. Okay, so then tool chains, it's talking about RISC-V and extensor targets. All of this, it's done. Okay. Yeah, okay, great. Then, hello world. Quick start, hello embedded world. Before diving into the theory and concepts of how everything works, let's jump straight into action. Use this simple code to turn on the onboard LED of the Espressif dev kit. Okay, to start the project, use ESP generate so-and-so, ESP32, ESP quick. Okay, this will open up a screen asking for options. All right. Then here's the full code. Oh, I don't know if this code requires unstable features. I don't think, no, 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 I don't think it does because duration is not unstable. I was thinking duration is unstable. I don't know if clock is unstable. Okay, anyways, I mean, I've done this already. I don't need to do this. Then cloning so and so, then flashing, cargo run release. Okay, now, man, okay, this is going into abstraction layers and I'm not able to show you. Should I like crash OBS? I think let me crash. Okay, so I closed OBS and the stream closed. I, for some reason, assumed that disconnect protection would save us, but it did not. Disconnect protection was not present there. Um, Wait, I don't know actually. Hold on. Like, what is the situation right now? Yeah, it's a new stream. I'm gonna have to stitch this again. Yeah, that is unfortunate. That is definitely unfortunate. I'm gonna have to stitch this. Anyways, this is, give me a second. Okay. So, this is where I'm at right now. Actually, now that it's shown up, I can show you guys this. Um, I'll just increase the size so you guys can see it. We're going to scroll through this real quick so you guys can see. This is the sculptures that I was talking about. They're called free Free-formed circuit sculptures. Holy shit. Yeah. Um, these are the sculptures. You can see like screens, and there's microcontrollers involved, and there's various other components like LEDs. Sometimes there's buzzers. You can see a capacitor here. There's a bunch of very interesting stuff. The circuit itself, this is the interesting part. A lot of times the circuit itself also contains or the sorry, the structure itself is also part of the circuit. I don't know if that's always the case, but in many situations I've seen that being the case. And I think this person also has done a couple of like um what do you call them, like time lapse videos showing how they've made this. I don't know if it was this person specifically, or if it was somebody else who was doing something similar and they showed their working process. I don't remember. But yeah, this is the kind of stuff that this person does, and it is really interesting. It's pretty awesome to see the kind of stuff that this person is doing. Oh, there's something here of this person building it. But yeah, dude, this is what I was talking about. This is interesting stuff. Now, let's go back, and I'm gonna keep the browser window big for now so that we are reading this. So I was reading this section earlier. We are done with this. Now we are moving on to the hello world thing. We are more or less done with this as well. I'm not going to be running that example because we are done with, we've done our hello world thing already. We already have like uh, a base project set up. We know how to do that. Okay, so abstraction layers. When working with embedded Rust, you will often come across terms like pack, HAL, and BSP. BSP is a new one. I don't think I've come across that. I did start coming across pack recently, which is peripheral access crate. HAL is hardware abstraction layer. Okay, these are different layers that help you interact with the hardware. Each layer offers a different balance between flexibility and ease of use. Let's start from the highest level of abstraction down to the lowest. Okay, so we have BSP at the top, then there's the HAL, then there's microarchitecture crate, and pack. I think microarchitecture crate has to do with the uh, the uh, the architecture of the processor itself, because that would change the kinds of instructions that it expects. I could be wrong though. Maybe microarchitecture crate means something else. Then we have the microcontroller itself. Okay, cool. So this is our, okay, board support package. A board support package, also referred a BSP, also referred as um, board support crate in Rust, tailored to specific. Am I reading this wrong? A BSP. Okay, okay. Let me. Fine. A BSP is tailored to specific development boards. It combines HAL with board-specific configurations, providing ready-to-use interfaces for onboard components like LEDs, buttons, um, and sensors. This allows developers to focus on application logic instead of dealing with low-level hardware details. Since there is no popular BSP specifically for the ESP32 Dev Kit v1, we will not be using this approach in this book. That's interesting. I thought they were about to say that the ESP HAL is the BSP in this case, because ESP HAL sits on top of HAL itself. But then I feel like each time, like I've said this in the past, right? And I feel like that's not entirely accurate because it's not sitting on top of it. Like conceptually, what it's doing is it is implementing a set of standard traits that embedded devices are supposed to implement, but the ESP HAL is still the HAL, and embedded HAL is not really, it's not directly involved here. It's what's being implemented. At least I don't think it's directly involved here because we usually don't touch embedded HAL when we are using ESP HAL. Um, but ESP HAL itself is embedded HAL based. It is built to it has been built by implementing embedded HAL for the ESP32. So I feel like, yeah, okay. Anyways, oh, mistake. Um, I accidentally hit the left arrow key instead of down. Okay, then hardware abstraction layer HAL. The HAL sits between the BSP level, sorry, sits just below the BSP level. If you work with boards like the Raspberry Pi Pico or ESP32 based boards, sorry, zoned out. Okay. If you work uh, with boards like the Raspberry Pi Pico or ESP32 based boards, you likely use the HAL level. The HAL builds on top of the pack and provides simpler, higher level interfaces to the microcontroller's peripherals. Instead of handling low level registers directly, HALs offer methods and traits that make tasks like setting timers, setting up serial communication, or controlling GPIO pins easier. Give me a second. Also, I was having a conversation with Gemini about um, one of the cheaper microcontrollers. Real quick, we're gonna take a short detour. Okay, it sounds like you've stumbled upon the big three of the modern hobbyist and professional embedded world. The STM refers to STM32 family of STM32 family by ST Microelectronics, and Pico is likely a typo for PIO or programmable I/O, which is the standout feature of the RP 2040, the chip inside the Raspberry Pi Pico. No, it wasn't PIO. It was Pico. Oh shit. Okay, I made a typo. Um, it was supposed to be Pico. I wrote PCIO, and that's why Gemini got a bit confused. Okay, the STM32 and Raspberry Pi Pico are excellent choices for no STD Rust. In many ways, they provide a more standard embedded Rust experience than the ESP32 because they use ARM Cortex M. They use the ARM Cortex M architecture, which is natively supported by the main Rust compiler without needing the custom forks often used for extensor-based ESP32s. Okay, cool, cool. Now, price. Okay, apparently STM32 does have microcontrollers in the cheap range. Yeah, yeah, apparently it does have microcontrollers in the cheap range. Hold on, are we still live? We are still live. Okay. Um, they keep mentioning that STM is good for industrial stuff. and they're saying like industrial motor control. ESP32 is best for Wi-Fi and Bluetooth IoT as an Internet of Things stuff. In a way, yeah, I am kind of building Internet of Things, but I'm not necessarily always using the internet or connectivity. I mean, yeah, okay, I might be using connectivity, probably. Okay, Raspberry Pi Pico is good for precise I/O and low cost. You can get them for $4. That's interesting. Okay, the Pico is often cheaper than the ESP32. It's famous for its programmable I/O blocks, which let you write tiny state machines to handle complex protocols like driving massive LED matrices or VGA without taxing the main CPU. Rust status, very mature. The RPRS ecosystem provides a solid hardware abstraction layer. Why try it? If you want to learn bare metal without the complexity of a Wi-Fi stack cons- constantly interrupting your code, the extremely no, it is extremely deterministic and great for battery-powered projects. Okay, then STM. STM32 isn't one chip, it's a massive family. You'll likely see the blue pill or black pill. Those are name choices. You likely see the blue pill or black pill. Rust status, this is the gold standard for embedded Rust. The STM32RS project uses SVD files, official chip descriptions, to automatically generate type-safe register access for every chip they make. Why try it? It's what the professionals use. It has very advanced timers and ADC capabilities that outperform the ESP32 in precision tasks like robotics. Now, okay, now I'm interested in it, or audio processing. Okay, then the no STD experience. While you're already using no STD on the ESP32, moving to ARM-based chips simplifies your tooling. Standard tool chain. You don't need ESP up or special compilers. You just need you just rust up target add so and so, and you are ready. Then embedded HAL. These chips are the primary drivers for the ESP HAL traits. This means a driver written for a sensor is more likely to just work on these platforms. Should you switch? Stick with the ESP32. You absolutely need integrated Wi-Fi and oh, if you absolutely need integrated Wi-Fi, okay, try Pico if you want the cheapest entry point, great documentation, and want to play with unique hardware features. And try STM32 if you want to learn the hardware, if you want to learn the industry standard and need high performance peripherals like high speed USB or CAN bus for automotive for automotive projects. Okay, so now I'm curious. Um, I'm gonna look this up. Raspberry Pi Pico. Hold on, dude. Okay, okay. This is actually a little cheaper. No, no, I would say it's a lot more cheaper actually because usually the ESP32s that I'm getting, if I get them, if I see them cheaper, it's often because of what do you call it? Because of discounts. Yeah, it's often because of discounts. But here, Okay, dude. I think I'm gonna explore Raspberry Pi Pico. I had no idea. Okay. Um, could you list out the cheaper um, Picos and STMs for me, please? Because, no, not because. Um, the cheaper, the better. I would like to have a bunch of these MCUs lying around for incredibly simple projects. Okay. If you are looking for quote unquote dirt cheap boards to keep in your drawer for simple no STD Rust experiments, you are in luck. In 2026, several ARM based options are significantly cheaper than ESP32 while offering excellence while offering excellent Rust support. Okay, the Budget King, STM32C0 some. That's insane. 25 cents to $1? No, hold on. That's insane. That is insane. Wait, let me see if it is actually that cheap. Now, something is there has to be like a catch of some sort. Hold on. What am I getting here? Two of them, I think. Maybe one, maybe two. Well, either way, I mean, it's holy shit. This is cheap. This is cheap. Okay, I need to also look into the programming for this because I'm seeing something here called ST-Link, and this has me wondering if these STMs also have that situation going on where I need to buy a separate thing to be able to program them. Okay, what's the next thing? Um, Raspberry Pi Pico, okay. Then STM32, it's called STM32 Blue Pill. So that's F103. So STM32 F103. Let's look that up. Um, okay. Okay, it's around the price of ESP32 or around almost. Might be cheaper. Maybe it's cheaper. Okay, then there was what 4401. Oh, these are slightly more expensive. So the blue pill one is three to $4. Then the black pill one, which is F401, is 450 to 550, as in $4.50 to $5.50. So I might not go for that. What did that say? 401. Okay. Change the search and okay, these seem to be cheaper. Okay, let's look up STM32 black pill. Right, so now I'm getting the ones within this price range. They still, dude, they still seem. Oh wait, no, they're cheaper, but similar to the ESP32, they are cheaper on offer. They're cheaper because they're on offer. But I'm very interested in that other one that I'd seen. Oh, this one is good. Blue pill is cheaper than black pill, though I think this is also cheaper on when it's on offer, when it's on discount. Now, what about that super cheap one, STM32? Um, breakout? Uh, okay. Okay, this might actually be super cheap. Though it says breakout. I think I think I need to do some research on STM32 boards and Raspberry Pi Pico boards as well. Or even if they are like not necessarily Raspberry Pi but like knockoffs, I don't mind that. Yeah, yeah. Okay. All right. Give me a second here. All right. Let's look. Okay. You know what? I'm gonna go to this person. Yeah, yeah. I'm gonna go to this person. I have no idea what they're doing. They're a PNG tuber. They've got some uh they've got some of those videos playing on their stream in which they you have like the it's like I don't even know what to call them, satisfying videos to look at. People cutting soap and making different types of things and stuff that's like satisfying to look at. I don't know. We're gonna go there. Let's see what this person is up to. I'm gonna start the raid. Yeah, that's gonna be it for today's stream. Hopefully tomorrow I'm able to start the stream earlier and then we'll make a lot more progress. Today we've reached here. I'm probably going to spend the rest of today doing more research on Pico and STM32s. And let's see if I'm able to come up with something cheaper. I might just go with one of these because it seems like the ecosystem is a lot more established, especially on the what do you call it? On the Rust side. Hell, I mean, Impel Ferris, the community that's responsible for this book that I'm currently reading. This community has also written a book for STM32. They've also written one for Pico. That's actually where I got it from, where I got these suggestions from. So we might have the documentation present right here, which is amazing. All right, that being said, I hope you guys have a nice day, and I'll see you all next time. Peace.